Algebra 1 skills number 24, arithmetic sequences with recursive formulas. So again, arithmetic sequence you probably know by now is a list of numbers that is constructed by adding the same number repeatedly. It's also known as a linear pattern. When you get to recursive rule, you've probably already studied the explicit or the default rule. And the recursive rule is a different way of going about it. It's a little bit annoying because they're easy to confuse the two, but there is a way that you can keep them apart. So recursive formula looks like this. Different look here. You see a sub n in there, and we saw that for the explicit formula as well. But now we got something different. A sub n minus 1. That was not in the explicit. And then we have d, which we did also have in the explicit form. And d, remember, is common difference. That's what's being added over and over. Now this a sub n minus 1 and this a sub n, which we had before, is just a current term. The position of interest is a sub n. A sub n minus 1 is really what is kind of the secret to recursive formula. A sub n minus 1 is the previous term. So if you're at a certain term or term of interest, a sub n minus 1 would be the term before that. Okay, and that's, again, the magic or the kind of what sets recursive apart. Recursive gives you instructions to go from term to term. Okay, so recursive is not as powerful as explicit. It doesn't tell you some term way down the line. It just simply gives you instructions to go from one to the next. It doesn't really care where you are in the sequence. Just how do I get to the next term? That's what recursive means. The explicit, which is not this video, but it's important to compare the two. The explicit from the previous is used to find any position. Okay, so just to compare the term. But we're going to focus on recursive here. Now, to identify it, this is key. The a sub n minus 1. Now, not just n minus 1. But a sub n minus 1. If you see that, then it's recursive. If you don't see it, it's the explicit. Okay, so that's how you keep the two apart. A sub n minus 1, because it's easy to confuse the two. So that's very important to learn. If you see a sub n minus 1, then that's going to be your recursive rule. And sometimes they'll do a sub n plus 1. Most of the time, those a sub n minus 1. And that's what we're going to focus on. Okay, so our first example, if a sub 1 is 3, and this is your rule. So let's focus on what this is saying. Find a sub 5. How recursive works is this. It's saying the current term is the previous term plus 6. So this plus 6 is the bridge from one term to the next. It just, again, it doesn't care what the first is, what the 50th is. All recursive cares about is how do you get from any given term to the next term. And here you add 6. So if we know that a sub 1 is 3, and again, recursive a lot of times doesn't care what a sub 1 is, but if we're given that, then the fifth term would be just simply adding 6 repeatedly until we reach the fifth term. So 3 plus 6 plus 6 plus 6 plus 6. Now, if you wanted to know a sub 50, and you were given the recursive, you would want to build the explicit to get there. You wouldn't want to use the recursive to go a long distance through a sequence. Okay, second example, write the recursive rule for the given sequence. So the sequence is this. And notice this time you're going down. I don't know if that even showed up in the last video, but it doesn't. The numbers don't have to be getting bigger. They can get smaller. Remember, to subtract is to add the opposite. So here your common difference is actually -6. Remember, if it's not obvious, just take any term and subtract the previous. 3 minus 9 is -6, for example. That's true for any of them. So to get from one term to the next, you subtract 6. That's what the formula looks like. A sub n equals a sub n minus 1 minus 6. This is your answer to example 2. A third and final example, the explicit rule for an arithmetic sequence is given by this. Okay, so this is explicit. Remember, if you don't see a sub n minus 1, then it's explicit. Only if you see a sub n minus 1 is it recursive. Write the recursive rule. Well, studying this, if you remember, the common difference is like the slope. If you recognize y equals mx plus b, this is the same look as y equals mx plus b. It's not the same letters, but 3 is in the same sort of M position. So that is your common difference. And that's how you build an arithmetic sequence. You add 3 over and over. This -2 is not relevant. to that. So you're going to just write the rule. A sub n equals the previous term. Again, if you see that, you know it's recursive, plus 3, and the 3 comes from that. So that's the recursive rule.